Section 4.3, trigonomic ratios. So today we're going to relate trig ratios to coordinates on the unit circle, determine exact and approximate values for trig ratios, identify measures of angles that generate specific trig ratios. So another little review, we're going to determine the general primary trig for the unit circle. So specifically for our unit circle, if we think of this as our unit circle, we know the radius of this has to be 1. This point on the unit circle has to be x comma y, so that tells me that this horizontal distance would be y, and this vertical distance, is x, and this vertical distance is y. And we're talking about this angle of rotation of theta. So if I were to set up each of our trig ratios in relationship to our sine ratio, which I know is opposite over hypotenuse, would simply be y over 1. And y divided by 1 would just be y. Our cosine ratio is adjacent over hypotenuse, which would be x over 1, simply just be x. And our tangent ratio is opposite over adjacent, which would be y over x. Okay, so in terms of this point, if you are working on the unit circle, then the coordinate of x on this point anywhere on the unit circle is going to represent our cosine ratio. So rather than write x comma y, I'm going to write this as cos of theta, comma, the y coordinate is always going to represent sine of theta. Now that's only if you're working on the unit circle, so make a note of that. Okay, and then our tangent ratio, which is y over x, could also be rewritten as sine of theta, which is y, divided by cos of theta, which represents x. Okay. In Math 30, we also introduced what are called the reciprocal trig ratios, which is what we're doing. We're reciprocating these primary trig ratios. So the first reciprocal trig ratio we're going to talk about is cosecant, which is the reciprocal of sine. And for short form, we say CSC of theta, so cosecant of theta. So technically what we are doing is we are reciprocating our sine ratio. So if we were to talk about our sine ratio in terms of our triangle, this is x, this is y, and not necessarily on the unit circle, this would be our radius r. Our cosecant ratio is the reciprocal of sine, so technically our sine ratio is opposite over hypotenuse. This cosecant is going to be the reciprocal of that, so it's going to be the hypotenuse over y. Or you can think of it as 1 over our sine ratio. The secant is the reciprocal of cosine, and for short form, say SEC of theta, and secant is going to be the reciprocal of cos. So cos would be the adjacent over the hypotenuse. Secant is going to be the hypotenuse over the adjacent. So we're reciprocating that, or 1 over cos. And the last, tangent, which is the reciprocal of tan. And short form, we say COT for cotangent, and that is the reciprocal of tangent. Tangent is normally opposite over adjacent. Cotangent would be adjacent over opposite, or the reciprocal of tangent of theta. Okay, so we're going to now introduce these reciprocal functions along with our primary trig ratios. All right, so using our unit circle that we drew out a couple days ago, we want to find the exact value of each of the following. So We're going to use primary trig ratios. We're working with positive angles, negative angles, radians, degrees. We're going to kind of all mash it all up. So sine of 210 degrees. So when you start to do these questions, we're just going to refer directly to our unit circle. So on our unit circles, look up 210 degrees. And I know as I rotate here, remember that my x-coordinate would represent our cosine ratio. Our y-coordinate is going to represent our sine ratio. So sine of 110 degrees should be negative 1/2. Tangent of negative 60 degrees. So negative 60 means I want to rotate in the clockwise position. So negative 60 would be result here, which would be equivalent to 300 degrees. And we're talking about tangent, and our tangent is our y-coordinate, so sine, divided by our x-coordinate, which is technically cos. So for tangent, I have to do a little bit of work here. I need to take my sine ratio, which is negative root 3 over 2, and divide that by 1/2. So now I'm going to simplify this. Dividing fractions, I multiply by the result. Those are going to cancel. So my tangent ratio is a negative root 3. Tangent of 3 pi over 4. Okay, well 3 pi over 4 is, I'm going to rotate in this direction. Here's 3 by 4, means sine over cos, or y over x, so 1 over root 2 divided by a negative 1 over root 2. Well, here I'm taking something by its own self, and anything divided by itself is always 1. But because this is negative, I'm going to get a negative 1. All right, now we're asked to find cosecant of negative 4 pi over 3. So a little trickier. 4 pi over 3, we want to rotate in the negative direction. So negative 3 would be past pi, because negative 4 is greater than 3. So I'm going to go past pi and up to here. So negative 4 pi over equivalent to a positive 2 pi over 3. Cosecant would be the reciprocal of my sine ratio, and my sine ratio is root 3 over 2. So when I do the reciprocal of this, I'm just going to reciprocate this ratio. So cosecant of a negative 4 pi over 3 would be 2 over root 3. But we never want to leave our answer with radicals in the denominator, so I want to rationalize this denominator by multiplying top and bottom by root 3 to give us a value of 2 root 3 all over 3. So the cosecant of negative 4 over 3 would be 2 root 3 over 3. Cos of 5 pi over 6, fairly straightforward. I'm going to look up a positive 5 pi over 6. Cosine is our coordinate, so it's a negative root 3 over 2. And cotangent of 270. All right, so 270 degrees is here. Cotangent is the reciprocal of tan. My tangent ratio would technically be y divided by x, but cotangent is going to be x divided by y. So cotangent of 270 degrees should be 0. All right, this is a question that doesn't lend itself to necessarily our 30, 45, and 60 degree reference angles. Okay, so it says the point A, which is at negative 3/5 and negative 4/5, lies on the terminal arm of the unit circle. Determine the 6 trigonomic. So negative 3/5 and negative 4/5 would lie maybe somewhere along here. No. Somewhere down here. Negative 3/5, comma, negative 4/5. So what does this tell me about this? And because it tells me that it lies on the unit circle, that tells me that my radius value is 1. It also tells me that because unit circle, my x-coordinate is going to represent my cosine ratio. So cos of theta would be -3/5. My y-coordinate is going to represent my sine ratio, which is -4/5. My tangent ratio is going to represent y divided by x. So I'm now going to multiply by the reciprocal. So those cancel. So my tangent ratio ends up to be a positive 4/3. And now it's asking for a 6 trig ratio, so I need to also do my reciprocal ratios as well. Well, reciprocal is just these values. So the reciprocal of cos is secant, which is going to be -5/3. Reciprocal of sine is cosecant, which is -5/4. And the reciprocal of, cotangent is the reciprocal of tan, which is going to be 3/4. And so those would be all of my reciprocated values. Now remember, you can only assume that this is your cosine ratio and this is your sine ratio when you're working on the unit circle. Okay, if you're not working on the unit circle, then you'd actually have to use your x and y values and use Pythagoras to come up with your radius. Okay. All right, so example 3, determine the approximate value of each trigonomic ratio. Use 4 decimal places. So this is something that you would do strictly on your calculator. And because this 10 degrees doesn't relate to our reference angles of 30, 45, or 60, calculate this on your calculator and you would not be able to write the exact value of it. It would just be written as a decimal place. So because your angle is in degrees, you want your calculator to be in degree mode. So make sure your calculator is in degree mode. And then you're simply going to type in tan of 10 degrees. And our ratio to 4 decimal places would be 0.1763. Okay, this next question, or let's go to cos of 260. That's fairly easy as well. I would type in cos of 260, and that ratio is -0.1736. Okay, what about a cosecant over 7? So what you want to do is, because you're working in radians, you need to change your calculator to radian mode. Okay, cosecant is also not an option on your calculator. So you have to do the reciprocal of sine. So technically this is the reciprocal of sine of 2 pi over 7. Okay, so you're reciprocating this entire value. You're not reciprocating the angle, you're reciprocating the ratio. So I'm going to go 1 divided by sine of 2 pi over 7. Oh, did I change my mode? Nope. Let's try that again. 1 divided by sine of 2 pi divided by, and the ratio should work out to be 1.2790. Okay, so when you're finding ratios, you need to, cosecant, you need to reciprocate that. Okay, all right, example 4, determine the angle to the nearest degree for the following. So we're asked to find the angle theta, which lies between 0 and 2 pi. So this is like the domain of the equation, and we're solving this equation basically for the value of theta. Because your domain is given from 0 to 2 pi, we need to answer in. So we are looking for when sine of theta is equivalent to 1 over root 2. Well, 1 over root 2 is essentially the same as, because on our unit circle it's not written as 1 over root 2. This is the same as root 2 over 2 as a rationalized value. So what we're going to do is we're going to go straight to our unit circle, and we're going to look up our sine ratio of a positive 1 over root 2. So remember, our sine ratio is our y values on our coordinate points. So 1 over root 2, or technically this is root 2 over 2. Okay, so one of my solutions would be 45 degrees, and then my other solution would be 135, but I don't want our answer to be in degrees, it needs to be in radians. So one of my answers would be pi over 4 and 3 pi over 4. I'm going to find all the values in a full rotation from 0 to 2 pi that would give us this ratio value. So my answer would be pi over 4 and 3 pi over 4. All right, what if your ratio is not necessarily an exact value on your unit circle? Okay, so in this case, you need to first of all find the reference angle that relates to this ratio by typing in the positive ratio of the ratio that you're given. So on your calculator, I'm going to go second sine 0.879. And I want to be working in degrees right now because that's what my domain is given to me in. And I get a reference angle of 61.5 degrees. And it asks for the nearest degree, so I'm going to do a reference angle of 62 degrees. So that's my reference angle. But then I want to think back to using the cast rule from Math 20. And I'm going to highlight my ratio for my sine ratio is negative. When is my sine ratio negative? My sine ratio is going to be negative in quadrants 3 and 4 because the cast rule tells me which quadrants our ratios are positive. So in quadrant 3 and 4 should be my solutions. So I'm going to take my reference angle of 62 degrees and I want to find that rotation angle or angle in standard position. So my position, because I'm working from 0, should be 180 plus 62, which is 242 degrees. This other solution, again with a reference angle of 62, is going to be 360 minus 62, which gives me 298 degrees. Okay, so how do you solve something that does not fall on your unit circle? By using your calculator, finding that reference angle, and then using that reference angle and the cast rule to determine which quadrants your solution should be in. Okay, next question. A little trickier. Tangent of theta is equal to root 2 from negative 2 pi to 0 now. So now I want to work from negative 2 pi to 0. So now I'm rotating from here to here. So all my answers should technically be negative. Next thing you should ask yourself, is root 2 an exact value? Does root 2 is ever equal to root 2? And the answer is no. So you have to solve this one. Even though this is an exact value, you have to solve it using your calculator. So on my calculator, again, I'm going to get my reference angle by taking second tan of root 2. And I get an angle of 55 degrees. Oh. But once again, looking at my domain, this needs to be in radians. So you'll notice that you're always switching back and forth from radians to degrees depending on the question you're being asked. And I get a radian value of 0.96. So this is my reference angle. So now I'm going to use my cast rule and figure out which quadrants I need to be working. And so my tangent ratio is positive here. So that means I should be working in quadrants 1 and 3. Remember the negative direction because we want to find the solutions from negative 2 pi to 0. So our first solution is going to be here with a reference angle of 0.96. So if I want to find this rotation, I'm going to have to go pi and subtract that angle. But because I'm rotating in this direction, I know my angle needs to be negative. So my first angle should be negative 2.18. And then my other rotation is going to fall in here. Reference angle is 0.96. This rotation I should be taking 2 pi and subtracting 0.96. So on your calculator, you should always be using your pi button. And I get 5.32 as my solution. And I know this also needs to be a negative angle. So remember, these numbers are in radians. Okay, so these would be the solutions. Okay, lastly, theta is equal to 2 over root 3. So now we're working with a reciprocal function. We're working from negative 180 degrees to positive 180 degrees. So I tend to break this up into 2 segments, all my angles that are negative and then all my angles that are positive. So technically, for the first part, this is my domain for the negative angles, and then the other part is going to be this rotation for the second domain. So I want to find everything here and everything here. I'm going to start by reciprocating this ratio and change my secant ratio into a cosine ratio, because I know secant is technically the reciprocal of cos. So I'm going to change this to cos of theta. But to change it to cos of theta, I have to reciprocate this fraction. So now this is an exact value that I can look up on my unit circle. So on my unit circle, I'm going to look up root 3 over 2, and I'm looking for when cosine is positive. Well, when is cosine should be positive in quadrant 4 and in quadrant 1. So if I'm going to rotate from 0 to negative 180, and in this area should be in quadrant 4. And that solution is going to have a angle of, because I'm rotating this way, a positive angle of 330 degrees, but I'm rotating in the negative direction, so the equivalent negative angle to that would be negative 30 degrees. Remember, cosine is your x unit circle. So root 3 over 2, my solution would be 30 degrees, and this would be a negative 30. So my solution theta would be a negative 30 degrees. And now I'm going to rotate in the positive direction, so from 0 to 180. So from 0 to 180, the only solution that I'm going to get should be in quadrant 1, and the positive root 3 over 2 cos ratio occurs here, which is at a positive 30 degrees. So what are my solutions for this equation? Would be theta has to equal to a negative 30 degrees and theta has to equal positive 30 degrees. Okay, lastly, an example of creating trig values for points that are not on the unit circle. So here's an example of, you're given a point, negative 4, 3. It lies on the terminal arm in standard position. What is the exact value of all of the trig ratios? Well, something like this, 4, 3, let's say lies here. Remember, I cannot assume that this is cosine ratio and this is the sine ratio, because these values do not lie on the unit circle. If these values lied on the unit circle, then these would have to be a value than 1, because the unit circle would always have a radius of 1. So in this case, we're not working on the unit circle as well at all, so we can't assume this is sine. We actually have to use Pythagoras to figure this out. So this x value would be -3, or sorry, -4. The y value would be 3. I'm going to use Pythagoras to find my radius of the circle. So my radius ends up to be 5. So now we can write all of our ratios. So sine of theta, right, should be opposite over hypotenuse, 3/5. Cos of theta should be negative. Tangent of theta should be opposite over adjacent, so -3/4. And now we need to do all of the ratios, also do the reciprocal ratios. Reciprocal of sine is cosecant, which would be 5/3. Reciprocal of cos is secant, which is -5/4. And the reciprocal of tan is cotangent, which would be -4/3. Okay, so there's an example of a point that doesn't lie on the unit circle. You have to use Pythagoras to find all of those trig ratios. And that is 4.3.